Hi, welcome in this tutorial. Today we are going to extract embeddings from our multimodal mimic data. At this time, you must have received an email containing a link to the data to download for the testing phase. If it's not the case, please refer to our GitBook page about the testing phase. The link is in the description. Let's start by creating a new workspace that we will be using during all the testing phase steps. So, this new directory is empty, and we will put the testing phase data in it. Go on your File Explorer, download the testing phase data if it isn't already done, and extract it outside of the workspace. Once the extraction is complete, navigate to your extracted folder. You will find at least 3 folders, one containing the CSV files from which we are going to extract data, one containing the images, and one containing the BioBERT weights for text extraction. These are all we need for this step 2. There might be other folders, but leave them for now. We'll also leave the images folder here because it is too large to be contained in the workspace and may slow down the application. Just copy and paste the CSV files we want to extract and the BioBERT weights into your workspace. Go back to the application, refresh your workspace, and you should see the data. You are supposed to have 8 CSV files right now. So let's start with the text extraction. I will not detail every functionalities of the extraction module in here because they already are explained in the general MEDomicsLab tutorials videos. Well, here we have 2 CSV text files to extract, the discharge notes and the radiology notes. Let's start with the discharge notes. Here I let the default selected options for feature computation by notes and master table compatible. For the columns, I select subject ID as patient identifier, chart time as time, and text as notes. For the column name prefix, I set in discharge, and for the name of the CSV file, I replace text by in discharge. Then I click on the Extract Data button. The extraction may take a lot of time, from 20 minutes to more than an hour depending on your computer, so start another activity while the extraction is running. Depending on your computer, you may be able to launch 2 or 3 extraction types at the same time. We will see that in a few seconds. Once the extraction is done, you will be able to display your result dataset, which contain your extracted embeddings from the discharge notes computed by the BioBERT model. Then you can see that your dataset have been saved under the Extracted Features folder. Let's proceed to another extraction. This time, select the Radiology Notes CSV. Like for discharge notes, let the Computes Features options by default. For the columns, select subject ID as patient identifier, chart time as time, and text as notes. Set in radiology as prefix and replace text by in radiology in the file name. Then click on the Extract Data button. If you feel that your computer is okay with one extraction, you can try to launch a second extraction at the same time. Otherwise, just wait until the end of radiology notes extraction to continue. So here I will start a time series extraction. We have 3 CSV files containing time series, chart events, lab events, and procedure events. Let's start with chart events. Let the default options for features computation by admission and master table compatible. For columns, set subject ID as patient identifier, HADM ID at admission identifier, admit time as admission time, label as measured item identifier, chart time as measurement date time, and volume as measurement value. Let the following option to minimal. Set the column name prefix to TS chart and add chart right after TS in the CSV file name. Finally, click on the Extract Data button. Like all the other extractions, the process will take a lot of time, so start another activity while the extractions are running. Once the 2 extractions are complete, you can observe that the related files have been saved under the Extracted Features folder. Now, we're over with the extraction text, so close the Relative tab, and let's continue with the time series extraction. Like before, you can try to compute image extraction at the same time by following this step on this tutorial, but I will not do it here. Well, this time we will extract data from the lab events CSV file. As before, leave the first options as default. For columns, the structure of the lab events CSV file is very similar to the chart event structure, so all the columns to indicate are the same as the chart events ones. Let the following option to minimal and replace tschart by tslab in the column name prefix and in the file name. Finally, click on the Extract Data button. Once the extraction is done, you will see that your CSV file have been saved under the Extracted Features folder. Now, let's do the same with the last time series CSV file, the procedure events. As before, keep the first option as the default. The CSV file column structure is similar to the previous one, but you'll notice that there are some blanks to complete. In this case, the measurement daytime is start time, and the measurement value is value. Let the next option to minimal and replace tslab by tsprocedure in the column name prefix and in the CSV file name. Next, click on the Extract Data button. This extraction is a bit faster than the previous ones because this CSV file contains less data. In the end, you will see that your CSV file has also been saved under the Extracted Features folder. Remember that you can take a look at your generated CSV file by turning on the Display Results switch. Here, you will see that your CSV contains a lot of null values. This is normal. Well, we are over with the time series extraction. You can close the Relative tab. Now, we are going to proceed to the images extraction. Open the Relative tab. The first step is to import the testing phase images folder. So, click on Select Your Data folder and choose the folder corresponding to the images, named Testing Phase Images. Once the folder has been imported, a success message will appear on the app. This may take a few seconds. Next, let's select the options. Keep the model weights as the default. For the features we want to generate, we only check Dense Features, which is the default option. Next, we want our data to be master table compatible for the next steps. So, we leave the switch on, and we import a dataset associating image file names with dates. This dataset is the image metadata CSV file. Then, we set JPG file as the file name column and datetime as the date column. Also, we check the parse patient ID as integer option. Finally, let the column prefix in the CSV file name as default, and press the Extract Data button. Once the extraction is complete, similar to other extraction types, your result dataset will be saved under the Extracted Features folder, and you will be able to display it on the extraction page. Well, that was everything for the second step of the testing phase. See you soon for the third step.